Going back from what I stopped, so talking about how we can come up with the idea of going from large language models to foundation models. Basically, the idea here is pretty simple. When the large language models were introduced in the beginning, it was very, as the name suggests, based on one modality, which is like language, the text, and with foundation models like Gemini, ChatGPT, DeepSeek, and etc., we'll have essentially a breakthrough in how these models can interact to produce the output. So we have multimodality in place. So they can understand text, they can understand images, videos, 3D assets. So the idea is that we can put like text, visual tokens, and the multimodal model will be able to produce the next token, which in the large language models are only rely on text, and we can produce the next token, which can be text, based on that information, which is multimodal. Basically, that's the idea. So, regarding the from foundation models to AI engineering, so basically in the past we have the ML engineering, and now we have AI engineer. So what changes? So basically in the past we have very task specific models. So the data science produce that. The machine learning engineer will be able to productionize this thing, produce monitoring for that. Um, you'll be able to track these decisions, make sure it's healthy or not. Um, we'll creating models from scratch. We need more complex infrastructure to host these models. And the idea is that right now we have more general purpose AIs, which are not tied to these big tech companies. So we are not like be able to have this power to train this. People rely on the infrastructure of these companies. So this is very bad. And we have a bubble in the investment mark regarding this because everyone wants to be part of this new breakthrough, and we now have like a new a new a new way to come up with this, which is the the model as a service. So big tech companies like AI provide super powerful models with trillion, billion of parameters that no one in house could train. And then the consequence of that is very large. So the people were not being able to talk about this, but the problem is that, as I mentioned, the people were more relying on this of this powerful of this model. So we are concentrating the power on these people. So yeah, going further about like use case. So we have the author like gives a very nice diagram about the users. So like 62% of the enterprise are using for text summarization tasks and enterprise knowledge management. So basically automatize FAQs of the company or tickets resolution. So these are the basically the current landscape of the usage, like taking into account that this book was written in 2021, so this could be changed for now for 2025. In the least usage is for recommendation algorithms and external chatbots. So basically that's the landscape. So yeah, so yes, the author also comments some where the impact of the usage of AI in different type of tasks. So the more impactful one is the code documentation. So basically, I think that's more straightforward and it all totally makes sense. Is to create automatic documentation from code. code generation, so it's been drastically increasing, so affecting also the interview process of teams. Code refactoring, and but in high complexity tasks, this being not too good. So the idea here is to understand where is we can be used. This is very important to understand what we'll be facing. Another topic, going to the planning AI application. So um, the first part is to use case evaluation. So um, the importance to understand if your business will be obsolete if you not adopt AI. I think this is a very tricky question because that's like related to the bubble that we are seeing right now. So people are thinking that they'll be obsolete because of this new breakthrough. It's not like even closer to AGI, but it's very, very impactful in the way that we conduct our tests. So the author also talk about like investing time to understand how it will impact you, because this will cost little compared to the gains that we will have. Setting the expectations, so how to measure the success of adoption of an AI app. So quality metrics to measure the chatbot responses. So we could have this could be like done by the human, or we can also plug another evaluator for that. Latency, like time for the first token. So how much time did you take the model to generate the first token? Um, Time per output token. So um, when what is the average time to produce each token, and also latency, because these models, if you compare with the like hard coded values, you can see that the main difference will be regarding the latency to produce the output. So if you just have a hard coded test, and if you have LLM, you have difference as a latency to produce these tokens of the model. So you want to minimize as much this time, so we can have like healthy apps. Um, the cost of inference, so many of these models could cost by the token generated, so you need to make sure that the model doesn't produce more tokens that you don't want, so you cost more than that. So it will be important to evaluate all of these things to come up with the right to use in your company. Also, the interpretability of the solutions, especially if you are using in your work, you probably will be assigned for the compliance or for other parts of the companies to understand what is being outputted for the model. So the model doesn't exist in a vacuum. So it needs to provide meaningful information about the decisions. So you need to take into account how interpretable is the outputs. The maintenance. So like this is a very important topic. I think that the author doesn't take too much detail, but we have like a lot of hype on the AI for creating stuff, but there's no much hype on maintaining this stuff, debugging this stuff. How could we leverage? How could we live in this day, in this world in which the majority of the code will be generated by an AI assistant, and we'll need to maintain these, evolve these, refactor these. So at least we know that we can use LLMs to do all of these things, but we need to make sure that we have the proper understanding and the trade-off of these code that is generated. So I would put more effort on detailing these in the book, but yeah, it's just a comment. Um, Talking about the AI engineering stack, so basically we have the application development, the model development, and the infrastructure. So the application development is an AI interface. So we need to have like good prompts, so we can provide like the context needed for the model, and this will be like the first layer for the model, and that's why it is the application development. So this is the part in which we will provide the prompts, we will provide the context, we will provide the interface for the model, and on a top layer, in a bottom layer, we'll have the model development. So we have frameworks for developing, for training, for fine tuning, and for inference optimization. So in this type, we have like inference optimization, dataset engineering, modeling and training, and the evaluation. And in the bottom above, in the bottom of the model development, we have the infrastructure. So here we have like more the backend of the part of the whole infrastructure. We have the tooling for model serving, managing data, computing, monitoring. So we have like basically these three concepts, but of course this can change for company to company. But basically this is like a high level understanding on how it is the stack of engineering works. So comparing AI engineering with ML engineering, so uh, so for the ML engineer, we have for the AI engineer, we have less focus on modeling and training because we have models as commodities, models as service, and we have more focus on modeling the application. So focus on what the user needs, what do we want to, the value that we bring to user, and as to the modeling perspective, because we will have these qualities as I mentioned. And also we have more focus on having efficient inference optimization, because we need to deal with bigger models. So we need to fine tune. We need to understand how we could enhance the current knowledge that these baseline models we have, these foundation models we have, and we need also to have an evaluation, because the output of the LLM are also very open-ended. So we need to make sure that it is making sense for our testing specific. So we need to make this process of adjusting the prompts, adjusting the things that we want for the model, and yeah, basically that's it for. Let me see if I have another things. So yeah, I think that's pretty much it regarding the chapter 1. In the next talk, I will talk about the chapter 2 notes that I've been following. But yeah, basically, this is like a very summary of the things that I noted regarding the book, regarding for the chapter 1. I think this is a very good chapter. I have some critics regarding some of the focus that it contains, and also some of the quotes that the author gives. But yeah, I think that's like they are very minor, but I understand the viewpoint of the author. But the TLDR is that like it provides like a very good landscape of these introductory for the foundation and LLMs. And in the next chapter, we'll deep dive on the foundation models in more details. So yeah, basically that's it. Thanks for watching.